Hexadecimals, and today we're going to be going over our TensorFlow object detection code. So basically, if we switch to Android Studio right now, we can see that we're taking the code from external.samples, and we're basically using the code that they have provided. We've copied and pasted the code into our current teleapp, and then we changed it a bit. So in this episode, we're going to be going over the code that they've provided, and then the code that we have right now, what we changed in the code and why we changed it. So let's first start out with the code they've provided. So let's go over their fields. So currently they have a TFOD model asset. This is a private static final string, and this basically is the folder that holds our assets. So next static final string that we have is label first element. This is the label that we're using for our first asset, and that is quad, so that's 4 rings. Second, we have our second element, label for the second element. This is also a static final string, and this is single, so this is for 1 ring. So if we scroll down to our next field, we have our next field being our static final string, Vuforia key. So now this is extremely important because since we're using a Vuforia engine in this code, we need a key for that Vuforia thing. So if we go up and to get a key, we click this link. Now if we switch to desktop capture, we can go to this link, and as you can see, I'm already signed in. But if you need to sign in, there should be a sign in button at the top. I'm gonna log out quickly. There should be a login button. It's currently blocked. Actually, let's see if I can move it. And that noise was the Vuforia thing. So basically, click the login button, and I'm gonna move my face back. And basically, you can create an account here. Since I already have one, I click login and get development key. And then here, we type in our name, so test, click this. This has the Vuforia agreement or whatever. You can reread this. Some of this could be important, some of it could not be important. Here I don't know what that means. Yeah, basically, you click accept, and you click confirm. This will give you the thing, but I don't need that because I already have the key. So once you have the key, you want to put it right here, copy and paste it in, so that you have your Vuforia key. When you initialize, Vuforia won't be null. Next thing, we have our Vuforia engine. So this is going to be like the main Vuforia sort of thing. And then next we have our TensorFlow engine. That's also going to be the main sort of TensorFlow field. So that's basically it for the fields. Now let's go down to our run up mode function. Here we have init Vuforia and init TFOD. So here we're initializing Vuforia, and then we're initializing TFOD. And an important thing is that order does matter. So since, as it says here, TensorFlow uses camera frames from Vuforia to create its sort of guess, I would say, at what the object is. So we need to initialize Vuforia first. So let's go down to Vuforia. Scroll down a bit, and let's go over this function. So here we're creating a parameters object, and this is just of type Vuforia localizer.parameters. These are the parameters that we're going to use to create our Vuforia engine. So here we're passing in our Vuforia key, and here we're passing in our webcam. So this is just using hardware map. In your configuration file, you should have a USB webcam, and the name should be whatever name you put in here. So how we're plugging in our current webcam is that we're using a USB hub. So the USB hub is plugged into the phone, and the webcam is plugged into the USB hub. I'm pretty sure there are other ways to do it, but that's how we're doing it now. So now that we have the parameters done, we just say Vuforia is equal to a new Vuforia engine with the parameters passed in, and as it says here, we don't need to load trackables. So now let's go down to our TensorFlow function. This line basically gets the camera feed on the RC. So basically, this will just produce a camera stream for the RC, so that you can see what's happening. So next, we're creating parameters, same as Vuforia, And now here is a very important part of this process, and this is the minimum result confidence level. So basically, when you compare two images together, you're never going, or well, you could be 100% accurate, but it's most likely the computer will never have 100% accuracy because variables tend to change. For example, lighting could change, where you are could change, you know, how the camera decides to saturate it could change, exposure levels could change. All of that changes, which means that it most certainly will never be 100%. And that means we need to have a minimum result confidence that we can say, hey, if you're 50%, for example, if you're 50% sure that this is it, then we're just gonna say, hey, we found it. So here it's 80%. And there's a very important balance to get right here, because you obviously don't want it to be too low, because then you're gonna just have a high error rate. But you don't want it to be too high, because that means you'll never be able to sense the object. So if it's at 100%, you most likely will sense the object 1 out of 1,000 times. Or if it's 0%, you'll sense it every single time, but almost certainly every single time it will be wrong. So that's important to get right. And as you can see, they're using 80%, and we are using 83%. So that is one of the changes we made. If you can see here, we're using 83%. So next thing that we do is we just say, hey, create a new TOFOD engine. So this is just creating the engine, same thing as Vuforia. Instead, we're passing in Vuforia here. That's why it was important to create Vuforia first. Next thing that we're doing is we're loading model from asset. So basically, assets are the images that we're going to be comparing to. So here we're passing in the location of the assets, or the sort of the file name where they're stored. And here we're passing in the labels. So we have label first element, that's quad, label second element, that's single. So basically, once we've done with this, we have finished our initialization process. So let's go up and let's see how we start sensing things. So here, basically we're saying if TOD doesn't equal to null, we're going to activate it. And also here, basically, this is saying that you can scale images. So you can zoom in on images or etc. It's also saying, this is very important to realize, is that you cannot sense images from like 2,000 feet away. You need to be close to the rings to sense them. So what we found out, and this was as a result of not reading this comment, which would have helped us out. Basically, we were trying to sense the rings from our starting position. So we were starting out a robot and we were trying to sense the starter stack. But that didn't work because it was too far away, so the error rate was too high. So what we did is we moved forward and then we sensed it. So always try to be as close to your targets as possible to get the best results. And of course here you can zoom, but that degrades video quality, and you don't want to degrade video quality because then of course it's harder to sense. Next we have telemetry data, pretty much self-explanatory, and here is where we get to the actual sensing part. So we're saying, hey, if TOFOD doesn't equal to null, again we're checking if it's initialized properly. So if it doesn't equal to null, we're going to call the get update recognitions. So this will return null if there's no new information available since the last time. But if there is new information, it's going to store it in the list of recognition items. And that's going to be called update recognitions. So this is now a list of items that we recognize. So if there's 4 rings, maybe there'll be like one item that says, hey, quad. If there's like 4 rings and then there's 1 ring on the side, maybe it will recognize 2 items. One of them will be quad and one of them will be single. So now we're saying if it's not null, so that means if we've moved or something, or there's a new image, we're gonna check again. So here we're just adding telemetry data. This is how many objects was detected. Pretty self-explanatory. For some reason this has integer. Oh, okay. Yeah, this was added by me. It should not be there. Oh no, that was actually not added by me. But it probably shouldn't be there. So this doesn't look like it was correct. So let me just double check that it is right. Yeah, apparently it's right. Okay, yeah. So basically, oh, because this is out. Okay, this is outside loop. So basically, we're creating I here, and this is our for loop. So the reason I was confused is because we're using I in another part of the program, in our own code, and they're using it here. So I thought it was somehow mixed up, but apparently it's not. So this is just for our for loop that's gonna loop through all our recognition items, and for each item it's just gonna present telemetry data. It's gonna have a label, left, top, right, bottom, etc. So this is basically it. That's actually fairly simple for sensing items. And once we're done, we just say, hey, if we have a TLFID object, just shut it down. So now that we've gone through the code that was provided to us, let me show you the code that I have now that we've created. So basically, let's switch to auto mode. Let's go up, and as you can see right off the bat, this looks a lot different. So now what we've changed is, since we're using location and object detection in the same file, we just decided to have one engine and basically copy and paste the code from that here. So as you can see, we're just creating webcam 1, self-explanatory. Here we're creating a camera stream to the RC. This is what was happening below here, and it's still happening. And then this line is commented because if we don't want the camera stream, we comment these two lines, and then we uncomment this line. But this just creates parameters, basically. Then we pass in our key, same thing, only our key has a different name now. We pass in webcam name, also similar. The only difference between what they're doing down here and what we're doing over here is that we have webcam. So we're basically storing a webcam name in a variable rather than just assigning it. So it's now in a variable, but it honestly doesn't matter. You can do it either way. Technically this is less efficient because you're using up more RAM. And then here, this is what wasn't done here in the other one, is we're setting use extended tracking to false, and that is for our location. And then we're just loading the parameters into Vuforia location. Yeah. So the main changes here were that we basically set this to false, and we have a stream to the RC. Both of the things we did because we're using location along with TensorFlow. Next we go to init TLFID, and this looks the same, and it's actually exactly the same, except for right here. So instead of 80%, we put it to 83%, which we find is more reliable, but does mean that sometimes it doesn't sense anything. So your mileage will vary, so it's better for you to start at 80% and do a bit of testing to determine what you find to be the correct threshold for you, where it's reliable and it doesn't take to and it actually figures out if the image is correct or not. And last change that we made is we just I put all of this, actually, well, not the last change, but another change that we made is I put all of this code, except for init, all of this into just one function down here, and it's just called setup recognition. You actually can't see the entire function, so let me do this. And yeah, we just have setup recognition, and then now, next change that we made, we have put all of this code inside a function. So this function is called find items, and see we have I is equal to 0 up here, which is why I was confused before. But basically it's the same thing. The only thing we've changed is we added ++I here, which we shouldn't have done. I don't think, at least. I think it's okay because we're looping once. However, do not do that. I would not advise that. actually. So for us, it's working, I think, because we have one object. When it gets to multiple objects, this will become extremely complicated. So yeah, actually, let's get rid of that. So then, actually, so yeah, okay. So we're keeping it here because for now it works with one object, and it should work. Actually, it's fine. So basically, we're saying telemetry.addData. So this is the same thing. We're doing a label left, top, right, bottom, all the telemetry. We're updating. See what we are updating here, and now we're saying this is the important part. If I is equal to 0, which means if there's no objects, we're gonna return null. Now the reason for this being important is I will explain later. Otherwise, we're just gonna return updated recognitions. So basically the same, except we have this if statement here, and it's in a function. Now, the only other thing that so now let's go over why it's important that that we have the return null. So how our code is structured. So as you can see, we're calling init Euphoria and setup recognition. So how our code is structured. Look, we start off, right? We drive forward towards the starter stack, and then we realized that to sense the starter stack, one call to find items isn't enough. So we're calling it 1.5 million times inside this for loop. That, however, takes a lot of time. So we're saying, hey, basically, data is equal to find items, and we're saying, hey, if data has actually found something, so this is where the null comes in. So if data has found something, just get rid of the for loop. Stop the 1.5 million iterations, and save us like 4 seconds. So this basically loops until you found an object, or it loops for 1.5 million times. And now here, as you can see, if data doesn't equal to null, if .get 0, since we have a list, we have to use an index 0. .get label is equal to quad, number of rings is equal to 4. If .get label is equal to 0, single, number of rings is equal to 1, and otherwise number of rings is equal to 0. So that is basically it for our TensorFlow code. So hopefully this helped you out with your code. One thing I actually want to mention is if you're having problems with Euphoria, it's always good to, well, first of all, it's good to look through the file again, because when I looked through it this morning in preparation for this video, I realized a couple of things that I hadn't realized before. So always look through the libraries one more time to make sure you understand everything. And also, so if Euphoria isn't working for you, you should try creating a new key. That worked for us. So for us, we were having runtime errors with Euphoria, and what we did is we just created a new key, inputted that in, and we were all good. So hopefully this has helped you out, and we'll see you in another episode.